All right. Well, those are the housekeeping items I have for now. So without further ado, I'd like to introduce our first speaker. Our speaker is Timothy Chick. Timothy, come on up.
All right, so welcome. Thanks for having me. Walk over here. Sorry. All right, so what I want to talk about is, does your DevSecOps pipeline function as intended? Why is that important, right? It comes from the fact that DevSecOps is really this really complicated system. And from a cybersecurity perspective, if it does anything besides function as intended, it means it's vulnerable, right? And so what engineering practice, how can I go through systematically from an engineering perspective, really try to argue that my pipeline only functions as intended, right? And it's free from vulnerabilities and blah, 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 right? That's really the focus of this talk. And kind of, if I'm gonna talk about DevSecOps, I can say, well, what it is. And then I'm gonna go through some basic 2 challenges. Challenge 1, I'll briefly talk about. Challenge 2 is gonna be the focus of the rest of the talk. And really how model-based systems engineering, along with building an assurance case, is really how you begin from an engineering perspective to make the argument that my pipeline only functions as intended. So what is DevSecOps, right? Kind of get it started. Who here has played whack-a-mole with security? Anyone? Right? The idea here is I'm going through some compliance checklist, or I'm going through here, and I'm just trying to hit the list, right? I'm playing whack-a-mole, hitting holes, or I'm doing patches and things of that nature, right? And a lot of programs, here's a reference, I'm not going to name them, but they had an 8-week stand down where they stopped doing new features, new functionality because they had really ignored their cybersecurity hygiene, right? They focused on the go faster, which a lot of agile and constructs are always focused on. Let's quick to market, things of that nature, right? So they were winning with features and effectiveness, but they were losing with defensibility and stability, right? And so we want to get beyond that, right? And so where are those tensions and why is that an issue, right? And I kind of like this diagram because it kind of shows where the tensions are, right? The idea of DevSecOps is to take a bunch of tools and processes across your entire life cycle and organize them in a way in which you get good throughput, right? Traditionally, they were stovepipes. You had your operations people, you had your security people, and you had your developers, right? But they actually have very different interests, right? Developers are focused on new features. They like change, right? If they're not building something, they're not doing their job, right? Security, they want defensibility. How do I defend this thing, right? And then operations people, they want stability. They hate change, right? They're being measured by uptime, and the system's always working and operational, right? And so they have different interests, so they clash sometimes, right? And part of that is they're also being squeezed by these 2 triangles, right? They're being squeezed by the balancing the benefits, risk, and quality, but they also have limited scope, time, and cost, right? Because I can't do everything, right? That's where the risk assessments, where the arguments and the conversations are is, well, I can give you this, but I can't do that, right? That puts a lot of pressure, and a lot of miscommunication, a lot of mistrust occurs. But from an enterprise view, right, whether I'm doing DevSecOps or I'm just software-intensive system, I only really care about 3 things, right? One is, why do I exist, right? Why is this company here? Why does this program office exist, right? The business mission, right? What's my value proposition? And the other 2 is my capability to deliver value. That's the pipeline, that's the infrastructure, that's the enablers, right? And then the product itself, right? And a lot of organizations, they talk about DevSecOps, they talk about processes, they always focus on the product, right? Reality is if you really want a secure system, you're going to have to focus on both, especially in the modern world where everything's integrated, everything's connected, right? Where traditionally I'd have my development over here, it might not even be networked to the internet, right? And then I have my product over here, and while I'd worry about the security of my product, I wasn't always worried about the security of my development, my pipeline, right? Well, with continuous integration, continuous development, they're connected, right? So I got to care about both. And it gets me into the challenges, right? So the first one is it's not static, right? I'm constantly changing, tools are changing, processes are changing. my product is changing, so that forces me to change my infrastructure, my processes, my policies, right? And then am I doing it right? Am I agile? Am I really doing DevSecOps, right? George Box, a famous mathematician, has been quoted as saying, all models are wrong, but some are useful, right? The same is true for process and tools, agile and things of those natures, right? Most of them, they say that, do this. This is how you do agile. This is the best technique. This is the best policy. The same is true for security, right? But the problem is not one size fits all, right? What happens is a lot of organizations come back and they go, well, we're kind of doing Scrum. Oh, we're kind of doing static code analysis. We're kind of, right? Because they're not doing what they think, the purists, the theorists are saying, this is how you should always do this, right? Well, reality kicks in and you can't really always do it the ideal way, right? That compromise, that balance, right? And the concept saying it's really hard to say whether you're doing it right because everyone does it differently, and that's okay as long as you systematically thought about how your pieces work together and how it fits into your value proposition, your product, and how it balances your capabilities and your services, right? And the risk associated with the decisions that you're making, right? And that's really the engineering part. How do we systematically do that without just the random whack-a-mole approach to solving different issues and problems that meet you, right? And so here's kind of a checklist of kind of how to work through picking the right techniques to do that. Like I said, I'm not going to really focus on that. What I really want to focus on is on challenge 2, right? The cybersecurity pipeline and the product, right? Traditional approach to cybersecurity was defend the network, build this moat around your product, right? Problem is like I said a minute ago, right? With DevSecOps, with this continuous integration, continuous deployment, what I've done is I have built super freeways, highways, over my moat into my product, between my development environment and my production environment, right? So now I've exponentially increased my attack vector of my system, because now it's not good enough, right, to just worry about my product and build that moat around it, right? I have to build a resilient product in addition to just defending the moat, right? And that's the main challenge that we have to face today, right? So from an engineering perspective, the way you do that is through software assurance, right? And here's a couple definitions. I've highlighted the software functions in the intended manner, and both of them are there, right? When I talk about assurance cases, I'll get to it in a few minutes, the other aspects of this definition, right? Free from vulnerabilities, either intentionally designed in the software, right? These are distractors. They're defeaters to an assurance case argument, right? Because if I only function as intended, then I am free from vulnerabilities. But the fact that I have vulnerabilities means I'm not only functioning as intended, right? And so from an argument, from an engineering perspective, my focus is functions only as intended. And I use risk management and I use data to build an assurance case that those defeaters to my assertion have been mitigated, right? That's ultimately what we want to do from an engineering perspective in building an assurance case. So the risk, right? We all know what risks are, right? But risk are really, in cybersecurity, is really based on perception, right? It's based on known attacks in the past. It's based on what you think is of value, what you believe is the attack vector, right? It's not as quantitative as we would like. It's really based on experience. It's based on knowledge, right? But what happens is we get misperceptions where I miscalculate that risk. I don't think that could ever happen to me, right? And so how do I balance that? How do I make that in a systematic way, that risk assessment? The biggest issue we have is interactions, right? We have a complex social technical system called DevSecOps, called our product line, right? Because it's people, processes, and tools working together, right? And every time those interactions occur, I have risk, whether it's a human risk, whether it's a open source third-party library that I brought in. These are all interactions and they're connections, right? I have to trust my dependencies. How do I assure trust? So these are things I struggle with. And then, of course, you have the attacker, right? And there's no one way, there's no perfect protection against the attackers because they're constantly changing their approaches to attack your system and to get across your moat, right? So how do I mitigate these risks, right? I can do it with an assurance case, right? And basically what an assurance case is I make a claim at the top, and I break it down and I go, okay, what supports that claim? What evidence do I have? What are my arguments to that claim? And then what are what defeaters could actually make my claim not true, right? What are the counter arguments to my assertions, right? So it gives me, a way in which to reason about the adequacy of both my pipeline and my product, right? From an engineering perspective, right? It also can be reproduced. Other people can come and they can evaluate my engineering work. They can peer review my work, right? They can find other arguments as defeaters. They can come up with other supporting arguments for my work, right? It provides this framework to actually apply engineering to cybersecurity. I'm not going to go over that slide. Right, so here's kind of what an insurance case looks like, right? I have this top level claim, then I have supporting claims, and then it's really hard to see, but there's a reference at the bottom. You can actually go open the technical report. It goes in really details about what this whole presentation is about. And then I have what's, the arguments and the evidence, right? As well as distractors and the evidence to go around the defeaters, right? So how do I do that, right? And so, back up for a second. So using software assurance and building assurance cases isn't a new technique, right? They use it in systems engineering. They use it a lot in safety, software safety, medical device safety, right? The difference is for them is they've coalesced around standards. They also have the laws of physics along their path, right? At some point, the plane won't crash, right? Because they have the laws of physics. We don't have that in security, right? Or in computers, right? Yeah, there's only so fast ones and zeros can go, but we're constantly changing those arguments and those equations, right? So how do we do that, right? And so from a DevSecOps perspective, if I want to build an assurance case, I need a standard. I need a systematic approach to define what DevSecOps is, right? And reality is, if you go Google DevSecOps, you'll find two things usually. One is, the infinity diagram, right? Some theoretical aspects, some basic principles and concepts of what DevSecOps is. Or what you find is someone trying to sell you a tool, right? This solves world hunger and does everything you ever wanted from DevSecOps, right? Those are basically the two things you find, right? Well, that's lacking from a standard perspective. If I want this organization, that organization, to be able to build an assurance case around DevSecOps, I need some consistency. I actually need a definition that was more fidelity than the theoretical or the sales pitch, right? So that's really in between what we call a platform independent model, right? Which I'm going to get into in a second. But that's what I need, right? If I'm going to do the same type of techniques practices that we've done for software safety or system safety using assurance case, I need a structure that's repeatable and consistent, that I can systematically go through my system and build my assurance case. That's someone else could go back, understand my assurance case, and review it and provide feedback, right? And do a risk assessment. So that gets me to model-based systems engineering, right? Model-based systems engineering is basically a digital twin of your system, right? Basically what you're doing is your requirements, your design, your data elements, instead of traditionally put them in various documents or wiki pages, right? What you're doing here is I'm putting in what's called a model, and then I create views into my model based on what I want to analyze or what I want to see, but I basically define it once and reference it often. That way it's always correct, right? Has anyone had the issue where you're doing documents, someone wrote it here, but they didn't update it over here, right? MBSE is trying to get away from that completely. Right? You say it once and you reference it as often as you need to, and you create views into the system, right? Because, and why do we have all these documents and wiki pages traditionally? Well, because what a developer needs to look at is different than what a security person needs to look at, but it's different than what an operations person needs to look at. But they all need to look at the same system, right? A lot of the data they're looking at is the same, just from different views, right? So MBSE allows you to do that, where everyone, even though I have different views of the data, if one person changes the core data, everyone sees that in their perspective views, right? That's where model-based system engineering is trying to get after, right? And so why does it work for DevSecOps? Well, because MBSE is really the modern current, most modern approach to doing systems engineering of complex systems, right? And DevSecOps is very complicated. A lot of people go, oh, we're doing DevSecOps, and they don't really think about the complexity of it all, right? Because what am I doing? I'm integrating different types of people, my operations, my security, my developers, my management, my contracts, my third-party vendors. So from the people perspective, they all have different tools. They're on top of different cloud infrastructures, on-prem infrastructures, a combination of both, right? Very, very complicated systems, almost as complicated as an airframe or an aircraft or a ship, right? It's just a different focus, right? And that's kind of goes to this argument, these slides here, right? So that's what creates, so how do I do that? How do I map this model-based approach to get me between the theoretical and the sales pitch, right? And that's what a platform independent model or a reference architecture is. It's basically, okay, give me more level of granularity of what this DevSecOps pipeline thing is. And then when I go build one, I can now reference it in terms of, is it complete? What have I done? What have I not done, right? And it becomes a de facto standard that anyone can use when they want to define their system and do a comparison from a model-based system engineering perspective. So I talked about what we've done. We've created this platform independent model because we didn't see the existence between those two, right? And what does it consist of, right? Well, so if I just use, unified architecture, architecture approach, right? It really breaks it down into these basic categories. And I'm going to quickly go through it because this is really the basis of being able to build that assurance case, right? And there's links on all these slides. I was hoping I'd have access to the internet, but they told me today I won't. Because I would have actually clicked in, because it's very interactive and you can see the different views and how they're all connected. But I encourage you to download the slides. I'm pretty sure they'll be available. And all these links are active, and they will actually take you to a live interactive model of DevSecOps, right? So I'm just going to kind of walk through what these things look like in these categories. The yellow box is requirements, so kind of walk through that. So requirements, right? So what we broke down is a little bit over 200 shall statements of what a DevSecOps pipeline should entail, from the different perspectives of developer, operations, security, management, the whole thing. What are all the things that I would need to do if I'm going to do the ideal DevSecOps? The thing people talk about theoretically, but pragmatically, what does that look like? What are those requirements that I have to meet to do a competent, good engineering job of it, right? So we went through and we defined that. We broke it down in some basic, looks kind of waterfallish, but it's just a good structure for putting requirements in, right? And we've mapped that out. And then what I want to look at is, well, what are the capabilities? So from engineering perspective, if I have requirements, I need to have, what capabilities enable me to meet those requirements, right? And this one turns out to be key when you build your assurance case. And so what we've identified is basically 10 basic capabilities one needs for a DevSecOps pipeline, right? And we list them here, and we actually go and we define them, what they are. There's actually 4 different views. There's links on the side, right? But really, configuration management, development, hosting services, integration, monitoring, planning and tracking, quality assurance, software assurance, solution development, and verification and validation, right? These are the 10 core capabilities one needs in order to actually implement a complete DevSecOps pipeline, right? From conception to production, right? And then I need to be able to, and I can map those, and that's kind of this eye chart on the bottom, is I can map those capabilities to which requirements are being addressed by that given capability, right? So I have that mapping. Here's my requirements, here's my capabilities. These capabilities satisfy these requirements, right? And then once I have those 10 capabilities, I now have the basic structure for my assurance case at the highest level, right? What I want to do is say, my DevSecOps pipeline only functions as intended. That's my main argument, right? Well, how do I break that down? How do I start making that argument that, no, really, my pipeline only functions as intended? Well, I can now structure that and say, okay, my next level of arguments or assertions, right, is that the DevSecOps pipeline provides planning and tracking services and functionality, right? Provides quality assurance, right? Basically, my next level of assurance cases is that I'm actually doing these 10 capabilities very well, right? But then that poses the question, well, what does it mean to do, planning and tracking? What does it mean to do, quality assurance, right? Or software assurance? Well, now I have to define the activities, right? And this is actually, to me, the most interesting part if I was going to do a live demo, right? This is the link I would pick, right? Because while at a top level, I have these two large blue boxes, right? The one on the left is kind of hard. It's the system main flow, which is really the pipeline itself, because the system in this case is the pipeline, right? And then you have the other big box at the bottom, which is the product itself, the product under development, right? There's two views of a system that I talked about, right? In this case, if I were to be able to click on that in an interactive model, it would take me down to the next level of activities, right? If you think about from an infrastructure perspective, right? This is where I'm going to think about my cloud services. This is where I'm going to be designing my my account management, my authentication tools and processes. I'm also going to sustain my help desk ticket, my troubling system from an administrative perspective, right? So we'll go into all those details, all those other types of activities one would expect to be able to do. We've defined them in our model, right? The product under development one, the bottom right, if I click on that, right, I have several levels of planning, right? So you have planning, you have development, you have testing, quality assurance, and then you have operations and sustainment, right? The basic life cycle one would expect a software product to have. But say if I dig into the planning, I clicked on the planning one, right? Well, what type of planning do I have to do? Well, I have to build an assurance case. I have to do cybersecurity. I have to plan for my quality assurance. I have to plan for my configuration management, right? And then I got to get into this whole, Scrum, Agile, iterative development, iterative cycling. How do all these different requirements, different plans feed into my planning and my execution, right? Those are lots of activities in there, right? And so what we've done is we've defined the activities without defining a solution or a tool to achieve it, right? It's platform independent, right? You pick whatever tool you want to use to do your planning. You pick whatever tool you want to do to build your assurance case, to do your static and dynamic scanning, right? We're just going to say you should be doing dynamic scanning here in terms of your workflow. This is the right place. This is where that activity usually occurs. If we can show the connection of those various activities, right? But then I get into who cares? The roles, right? A lot of times when you look at literature, when it talks about DevSecOps, it's almost always written from the developer's perspective. Have you noticed that? I don't know if you have or not, right? But there's a lot of other people who care about the pipeline, right? And so what we've done is we've gone through and we've decided, well, what are the critical roles, right? You have the business perspective, right? It's hard to see there. It's hard for me to see here, right? From the engineering perspective, right? I have developer champions. I have the release engineer. I have the site reliability engineer, the architect, the software developers, the only one most people focus on, right? But then I also have the user experience, and I also have cybersecurity engineering, right? It's some basic critical roles. But then go next step further, right? If you click on one of these links, we've actually defined all the roles and responsibilities that one who's performing that role cares about, right? We also talk about, what are the main questions that they're asking from a goal perspective. What's the goal of that role? What are the things that they care about? What are the core questions that they're going to ask, right? Because that would also help you feed some type of metric system if you get to that point. What measures will help me answer these questions, right? So we've gone to that granularity. It's even more of an eye chart if you bring that up, but it's very interactive and you can see it in the model. Oops, wrong way. Sorry, wrong button. All right. But so then what I can do is say, for a given activity, I can map it to the roles. Which role do I care about, right? If I care about that particular activity, do I just want to be informed? Am I actually the driver, the one implementing that activity, right? A basic RACI matrix, right? I can make those connections. And I can look at which activity, who cares about which, right? And that was a long-winded, I need all of this to even begin thinking about cybersecurity. Because now once I have those activities, once I understand what they are, understand the human interactions with it, and the purpose of those activities, I begin thinking about what are my threats to those activities, right? And so what we've defined is a basic template for writing a good threat statement, right? I need to care about the activity, right? In the model, there's blue boxes, a little bit more granular, like planning, testing, developing, writing code, those types of activities. Who are the actors involved, right? What's the action, right? The potential occurrence of an event that might damage an asset, mission, or goal. What type of attack? What's the asset? What's the effect? What's the objective? And once I have those elements, I can actually write a statement, right? The examples here is an insider threat publicly releases the results of a static dynamic analysis to the public to damage the organization's reputation. I could also say, and also to provide, very valuable data on how one could attack my system, right, if that was to be released, right? So you can vary and write multiple threats given certain variables and data, right? But once I have that, right, and here we've developed some type of workshop, kind of like a desktop exercise, kind of walk through how do you brainstorm, how do you systematically go through all the activities with a group of experts or knowledge people within your organization, from security, from developer, right, and actually start building these threat scenarios, right? So the basic workshop for doing that. But once I do that, I can begin modeling it, right? So here's a view of that. It's another eye chart, sorry, the link's on the right. And so the blue boxes here are the threat scenarios, right? So I can actually say, for this given activity, right, of writing code, right, we've identified these 4 threat scenarios, right? And what I can say is who's the performer of these activities, right? So basically, it's the developer. The software engineer is basically the one, really the performer of these activities, right? But then at the bottom, I say, well, who's actually the attacker, right? And it's interesting, I believe one of these, yeah. It's the user, right? There's another one in the model somewhere, where it's actually the developer is also the insider threat, right? They're also the enabler of that particular threat scenario, right? So I begin modeling that, right? And I can go look at, the MITRE attack framework, I think that's a KPEC, right? And I say, okay, how would one enable that particular type of threat scenario? How would one actually be able to achieve that scenario, right? I can begin mapping that, right? And this is just for the platform independent model perspective, right? The next step when you have an actually instantiated pipeline would be, okay, if I understand these threats, I understand these activities, how am I mitigating them, right? How am I defeating or overcoming those defeaters to my assurance case that my pipeline only functions as intended, right? So I can systematically begin looking at every activity, I can capturing this data, right? I can also start showing how I'm mitigating these attacks from a model perspective, right? So the developer understands what they're responsible for, and as well as all the other roles, right? Right, and so then I can begin looking at the threats to a given activity. So I can begin building these matrices, right? And this is just an example. Ideally, you'd have a lot more threats, and you have a lot more connections, right? Right, you say, okay, because some threats might be duplicate. Maybe this threat is the same threat for multiple activities in your system. Well, that might be an indicator of a higher risk. Maybe I should definitely make sure I mitigate that one because it actually impacts multiple activities in my network, in my pipeline. Right? I can build a list of tables, right? These are just different views of the same data, right? And this is really the power of model-based systems engineering. I say it once, and I can build different views into my data to abstract out, to answer the questions that I want to do as part of my analysis or as part of my evidence for my assurance case. Here's another one, right? This is focused on, for configuration management, one of those 10 capabilities, right? Here's all the threats to that capability, right? That's all the blue boxes in the bottom. All the pinkish box on the top are all the requirements being satisfied by configuration management, right? So you can say, okay, configuration management enables all these requirements, and it also has all these threats against it, right? And the idea there is then, well, what are my mitigations to those threats? Have I thought through it from an engineering perspective, right? And did all the appropriate analysis, right? And that's really how I identify, based on identifying those threats, because each one of those threats is a defeater to my assurance case, right? Because I'm saying I'm doing great configuration management. I've done it all. I've met all the requirements. Yeah, but I could attack your CM process, right? I could, maybe inject something to change your release product, right? Before you've, done your crypto, you've encrypted it or added a key, right? these are the threats. These are defeaters to my argument that my configuration management only does what it's supposed to do and nothing else, right? You can't exploit it, right? Those are defeaters to my assurance case. So you can, and some people say, well, this is very documented, very system engineering, it's a lot of work. Yes, it's a lot of work, but things worth doing usually are, right? But you can work it into your agile processes, right? You can iteratively build your model. You can iteratively do your assurance case. You can iteratively do those analysis and mitigations. So it's not a one-time analysis and you're done, right? Every time you add a new tool to your pipeline, every time you change a configuration to your pipeline, right? Now I can go back to my model and go, okay, I'm changing my configuration management tool. Okay, it was working today. What are all the arguments the new tool has to meet? What are the threats that I need to make sure I mitigate, right? I've done that analysis, I've done that engineering, but I know exactly where configuration management is actually interacting in my system or in my processes, right? Where are the touch points, right? And having that model, having that brought out and built out allows you to figure out what's the implication of a new tool? What's the implication of making this change to my system? What's the implications of doing this, right? I can think about it before I do it, right? And it gets me out of this reaction mode, right? How many people have done something to their configuration or installed a tool and then went, oh, wow, I didn't realize that broke this. I didn't realize that impacted this, right? That's really what model-based engineering is trying to get around, right? If I model it properly, I can do good engineering analysis, and I can plan and I can engineer good solutions before I just try it out and see what happens, right? And that's the whack-a-mole approach, right? We just try it out, see what happens, and we just hit all the holes until it stops, the moles stop popping up, and they never stop popping up, and so it's a never-ending game, right? That's what good system engineering is all about, and that's what we need to start applying to cybersecurity to be effective and really get there, right? And so the PIM does lots of things. But the main one that I've talked about today is that last bullet, right? Provides the basis for threat and attack surface analysis to build a cyber assurance case, right? That's really what we want to get after. Like, let's do good software systems engineering to our products and our services from a cybersecurity perspective. What are those threats? How do I build that in? How do I mitigate them? How do I engineer in a resilient product, right? Versus just focusing on protecting the moat, right? And that's all I got. Because I have a few minutes for questions, if anyone has any. Sure. Right. So if they've already done a lot of those things, right, the easiest thing for you to do is, okay, I have this platform independent architectural model, right? Tell me how you've solved these things, right? So they have some tools already picked, they have some automation, they have some processes, right? So I can just begin mapping their solution to my model, right? And then what I'm going to find is, okay, if they map to this piece, did they think about these threats, right? Or I'm going to say, well, you know what? I see you're really strong at this part of these activities, but you really have nothing for static code analysis, right? You have nothing for, maybe your planning's off, right? So, okay, yeah, you're doing this Scrum thing, you've got your tickets, you're doing your every 2-week sprints or whatever, but you're only focused on the product owner. And the product owner is only focused on features or capabilities for the end product. Where is your security features? Where's your security stories, right? How are you building that list, right? Because the reality is, if they don't have those things built in, either as their definition of done, because it's already been defined, it's already there, right? But if I want new security features, new security capabilities, well, that's stories in a backlog to somebody, right? And so one layer at a time, one iteration at a time. I wouldn't want to overwhelm them, right? I'd pick on where they are at today and say, okay, if you're focused on automated testing, great. Let's just focus on those activities, right? We have this reference model. I can see where the gaps are, and then let it grow naturally from there based on where they're at and what they're interested in. That helps. But it's not fun, it's not easy. They're going to have to do some engineering work, right? But right, but what they don't understand, though, is part of that is because they didn't think about security from the beginning, right? If you don't engineer it in, you hit this brick wall of it's not secure, you can't deploy, right? How do you avoid that? Well, do some good engineering up front, right? That's really what I'm trying to do. I'm trying to get people to say, okay, I understand where security came from, historically security was very operations focused, build the moat, all about the network, defending the network, right? Well, it was never really completely adequate. Now it's like really not adequate, right? With this whole integration and whatever, right? So we got to move the engineering disciplines. We got to get them to say, okay, I got to focus on, and I got to design in resiliency. And the only way to do that is to make them start doing engineering from a cyber perspective, along with all the other engineering they're already doing to solve the capability piece. Yeah, I believe they're provided on the website at some point. Yeah. Yeah. And if you don't get it, my contact's right here. If you email me, I will send you the slides. And I can send you a link to the model. You can just interact. But I like the slides because the model can be overwhelming from a starting point. So this kind of gives you views into the model to get your head around it a little bit. Right. So it's a balancing act, right? Kind of like before, like just focus on one area and expand based on the experience, right? The model can be overwhelming. Pick an activity, go where they're at, what they're currently focused on, what they think their current pain point is, right? Because they're more interested in help if you could align with one of their pain points, right? But the other part of it in terms of what you're saying is, well, do you want us to fix the problem? Do you want me to do engineering? Well, do you always want to be putting out fires, or do you want to do some fire prevention, right? And I get you got to put out the fires, but if you don't start investing in fire prevention, the fires will get out of hand, right? And so you got to balance it, right? And that's even a best practice for agile people, right? So, when you do your sprinting, right, it's not 100% new features, new capability, right? You've got to, the Scaled Agile framework, they call it the architectural runway, right? You got to invest in the future because what will happen is you'll be so short-sighted, your technical debt will get out of the way, and it will actually reduce your productivity, right? Which might be what they're experiencing, right? They have so much technical debt because they've ignored those things, right? That their productivity is taking a nosedive because it's hard to give you a new feature because certain pieces of my code are so fragile, right? Same thing's true from the security perspective, right? If you patched in certain security aspects that weren't designed in, well, that adds more debt. That makes it more fragile. It makes it easier to break when I make a change. Yeah. Yeah.
Two-part question. On your slide 43, I'm trying to get an idea of where you see the security architect playing a role, or if that's some sort of a shared role model across the boxes.
Right. So I think you should have a system engineer and architect, right? And usually, most people, when they talk about Agile, they focus on the product owner, right? Which is really just the voice of the customer, right? Well, that's okay if I'm doing this small little 5-person project, and that's all it is. But if I'm doing a team of teams, I'm doing this larger construct, right? That's no longer adequate, right? I really do need an architect. I need a systems engineer. I need some cybersecurity. I need some specialties, and they should be feeding my pipeline, right? They should be writing stories from security perspective. They should be writing stories from, architecture, build an API or whatever is needed to enable the product's owner's requests, right? And what that balance is, right, depends on where you are in your life cycle, where you are in your structure. A good rule of thumb is at least 20-30% of your backlog that developers should be working every sprint should be the architectural, the enablers to future stories or future functionality, future features. Right? Because if they don't do that, the technical debt will get out of hand and they'll hit this wall of ability and their productivity will take a nosedive. Did I answer your question?
In part, I'm trying to figure out between the architecture roles that are displayed on screen, what part of that is the security architect, or if that's something that's spread across different feeds. And I'll give you some context. From a financial institution standpoint, looking at a large scale tier 1, tier 0 development exercise, interdisciplinary teams, multifaceted teams, delivery PMOs, there will be lots of security architecture requirements that would need to be escalated or de-escalated. With the agile model, lots of moving parts, trying to figure out where that role fits, or if that's a fluid concept in this diagram.
I believe you should have representation in every one of these blue boxes. Because the things I think about from a cybersecurity perspective when I'm talking with a developer is different than when I'm doing enterprise architecture, right? But there are cybersecurity implications at each one of those boxes that you care about, right? Enterprise architecture, I might be looking at, some, multi-factor authentication that the whole enterprise is going to use, right? But I'm gonna put the requirements for that in the design in my higher enterprise architecture perspective, right? And then when you get down to the developers, you're getting more into like, how would you build that specifically? What are the nuts and bolts of that, right? So you need to be representing each one of those. Yeah. Right, so I don't know if any of you have actually done all that I've said here, but in terms of model-based systems engineering, lots of organizations, well, if I'm building a system, it has software in it. Right. There's a whole list of people who've done model-based system engineering. I don't know. Let's see. Where's that? I believe there's some financial institutions in that list. Sorry, it's one slide at a time. Yeah, these are mostly physical systems, I guess, in this list here. Well, there's Philadelphia Insurance Company. They're nothing hardware in there. There's a reference 6, basically no magic, basically Cameo. They have a website somewhere that lists all the different major corporations that are using MBSE. Huh? I think I'm out of time, but I'm happy to answer questions. I believe I am. My moderators. Am I done? Yeah. So I don't want to make you late. I will be here afterwards. If you want to ask me questions, feel free. And my contacts, last slide, wherever that is. Thank you.